Hello and welcome to my presentation. The term carbon footprint is frequently in the news. An increase in greenhouse gas emissions and therefore in carbon footprint is the primary event associated with climate change. One way to decrease our carbon footprint is to improve our sustainability. In broad terms, sustainability within the workplace or laboratory means ensuring our processes impact the environment as little as possible. Some examples of how sustainability can be improved within the analytical laboratory include reducing analysis cycle times and improving efficiency of laboratory tasks, reducing the amount of solvent we use, recycling, and also going paperless. Aerodynamic particle size distribution is widely recognized as a critical quality attribute for the in vitro characterization of all inhaled products. The preferred instrument of choice for measuring APSD being the multi-stage cascade impactor. APSD is one of the most significant tests within the inhaler laboratory in terms of analysis time and solvent usage, and with increased interest in sustainability and the reduction in carbon footprint, these are both areas where improvements can be made. Abbreviated impactor measurements are a possible alternative with numerous benefits over their full resolution counterparts. With an abbreviated impactor, we see increased productivity, simplified apparatus, easier route to automation, and reduced solvent usage. It is this transition from full resolution impaction to abbreviated cascade impactors that will be discussed within this presentation. This study was conducted with a next generation impactor from MSP Corporation using a standard USP throat, an RNGI filter holder assembly from Copley Scientific, a combination pressurized metered dose inhaler containing an ethanol-free suspension formulation of salbutamol sulfate and ipratropium bromide monohydrate. All analyses were conducted at a fixed flow rate of 30 litres per minute. The active pharmaceutical ingredients deposited on each component was recovered using a suitable solvent and quantified against calibrated standards using an Agilent 1100 HPLC. This methodology was validated for specificity, method precision, accuracy, and standard stability. The image on the left shows a standard NGI configuration with the associated cut points per stage. Depending on the flow rate to be used, a stage of the NGI can be selected having a cutoff diameter close to the product MMAD or close to 5 microns. The RNGI filter holder assembly is placed in the stage immediately after the cutoff stage selected. The image on the right-hand side shows the RNGI configuration used for this analysis, in which the filter is placed on top of stage 5. This RNGI configuration was deliberately chosen to allow measurement of MMAD based on prior knowledge of the MMAD from previous NGI data. Using this configuration, we reduce the number of stage-based samples by 45%. The APSD data generated was used to assess for equivalence in impactor mass, impactor sized mass, fine particle mass, mass median aerodynamic diameter, and the ratio between large particle mass to small particle mass. From the data generated, we can see that there is less than 3% difference observed in impactor mass and impactor size mass for both APIs, and less than 10% difference in the observed data generated for the ratio of large particle mass to small particle mass, again for both APIs. And there is no statistical difference observed for all metrics. For fine particle mass and MMAD, these data were calculated using SITDAS software with a 2-point interpolation between the data from stage 4, stage 5 through to filter for NGI, and stage 4 to filter for RNGI. Again, there is less than 3% difference observed between in FPM and MMAD for both APIs, and also there is, again, no statistical difference for both metrics. Any observed differences could be associated to the multiple sources of error associated with cascade impactor analysis. In conclusion, this study has shown that the simple addition of a filter paper onto an existing stage of an NGI can provide product-optimized, reduced next-generation impactor configurations. We have seen that there is no bias between the NGI and RNGI, and comparable data is achieved when using an RNGI configuration to determine abbreviated impactor measurements. With a reduction in stage-based samples, improved efficiency, increased throughput, and reduced solvent usage can be achieved when using an RNGI. From the example shown in this presentation, we could have achieved greater sustainability with AIM had we not required MMAD estimation by moving the filter paper from stage 5 to stage 4. With this configuration, we could still determine fine particle mass. It is considered that increased sustainability via the use of AIM can only realistically be realized with the adoption of such methods into the pharmacopoeias. Potential further steps that could again increase the sustainability would be to transfer HPLC methodology to UHPLC and to assess and transfer to reusable filter papers. Thank you very much for listening, and that concludes my presentation. Please submit any questions via the text chat.